Yeah. So in the last class, we discussed some if-else examples. Today, I want to discuss the difference between if-else and conditional operator. This conditional operator is also called ternary operator. You would have we discussed this once, and you also would have learned it in your labs, etc. So let's take the regular example. Suppose if I want to say what is max given two numbers, if a greater than b, then I want to write max equal to a, else max equal to b. Now the same thing using conditional operator. How do we write it? Does anyone remember? A greater than b, question mark, a colon b, and for this entire thing we write max equal to. Okay, so this has three parts. This is the first part, this is the second part, and this is the third part. So the first part is the condition. Directly whatever condition you are putting in the if statement, same condition is the first part. The second part is the statements in the if part of the if else statement. So if this condition is true, whatever you want to do, those you put here. The third part is the statements in the else part. Okay, but these are not exactly the statements, the entire statements. There are some differences between if else block and this conditional operator. In if else block, you can have different kinds of statements. You can have not only expression statements, but you can also have return statement or break statement or jump statement. You remember different categories of statements, looping statements, conditional statements. So all those things we can have. Even if else, within that again if else we can have, or return statement we can have. But here we can have all these three parts. They can only be expression statements. They can't be any other kinds of statements. If you put any other kind of statement, it will not work. Okay, so what this does, if this expression is true, then it will return the value of this expression. If this expression is false, it will return the value of the third part. Okay, so that's what happens. So finally, either the value of the second part or the value of the third part becomes the value of this entire expression, depending on whether the first part is true or false. Okay, so let's once run it and see. So let me declare two integers. Let me scan them. So now I will also declare x. So a greater than b, question mark, a colon b. Okay, and then we print the value of max. Okay, let's run it. I'll give say 5 and 10. I got 10. I'll give say 15 and 12. We got 15, right? So whatever is the max number that is being stored in the variable max. So now let me modify it slightly. So what do you think will be the result now? Will it give the same result, or will it be different, or what will happen? Same result. How many of you think it is the same result? Okay. How many of you think it will give a different result? How many of you think it will give an error? Okay, let's see. Giving an error. Why? Because these are not expression statements. Like I said, all three parts in the ternary operator. Ternary operator itself means there are three arguments. Binary means two arguments, unary means one argument, ternary means three arguments. So all the three arguments in this operator have to be expressions or expression statements. Basically, they should have a value. Okay. So like I said, except expression statements, nothing else will have a value. No other kind of statement will have a value. So is a return statement an expression statement? No, it's a jump statement. If you remember, return, break, continue, exit, these are jump statements. Okay, both of you got out, both the boys with specs. And I want your roll numbers also. Come here quickly. Fast, don't waste my time. Yeah, what are your roll numbers?
Sir, 055.
AI.
ECM.
055. Yours?
AI 11.
113.
Yes.
Okay, go. So return statements are jump statements. They don't have a value. Okay. Expression statements have values. So whatever is the value of the expression statement, that value will be assigned for the entire ternary expression or the conditional expression. Okay. So that's why you can assign this entire expression to some variable. So this entire ternary or conditional, when you're using a ternary operator or a conditional operator, that entire thing itself is an expression again. So each of the arguments, three arguments is an expression, and this overall thing is again an expression. So you can assign it to some variable. All right. Now let me modify it slightly. Suppose I say percentage D is greater, and that is A. Here I'll say it is B. Okay. So will this work or will this give me an error? Return I should remove. Yeah. Yeah. Will this work or will this give me an error? It will work because these are also expression statements. Printf, scanf, input output statements are also expression statements. Any operations are also expression statements. Assignments are also expression statements. So in this, instead of printf, you can also put some a equal to b or those kind of statements also. That overall will also have a value. Okay. So here, if a is greater, it will print a is greater with the value of a, or if b is greater, it will print b is greater with the value of b. What will be the value of max? The total number of characters that are printed. So max will not get the value of A or B. Max will get the value of number of characters printed by the printf statement. Okay. So suppose if I give say 2 and 100, A is 2, B is 100. Then first what will it print? Yeah, 100 is greater. And then what will be the value of max? Yeah, how many characters are there? So 100 itself has 3 characters. And then space 4, then 5, 6, space 7, 8, 9, 10, 11, 12, 13, 14. This new line is 15. So max will be 15. Okay. it printed the second statement and said max is 15. Suppose I give 5 and 2, then first what will it print? 5 is greater, and max will be 13. You just reduce 2 digits, 2 characters. That's it. So printf, scanf, etc. They're also expression statements, so they can also be used. Okay. Right. Yeah. So I hope now you understood the difference between if else and conditional operators. If your decision is quite simple, just if this is the case, then usually if it is assignment or just evaluating some expression, use conditional operator. If it is too complex, use if else. If your decision making program have or has some statements which are non-expression statements, then you necessarily have to use if else. You cannot use conditional operator because it can use only expression statements. Okay, you can nest your conditional operators also, but that is slightly complex, so let's not get into that right now. Just understand one level of conditional operator, and you have to use only expression statements in conditional operator. That's all. These are the two things you need to understand. Okay. And next, now let's look at some scenario, say where say each country has some code. Suppose if I say A is for America, say B is for Brazil, something like that, and so on. Suppose I say I is for India. Okay, let's just take these 4 characters, and these 4 characters represent 4 countries. So each character is like a code for a country. So I want to write a program. Say the user does not know what each code stands for. He inputs the code and we should output the country name. Okay. So one way of writing it is, so first let me write the pseudocode. So we say, so first we say we declare the character, then we scan the character, and then we compare if ch equal to a, print America, else if ch equal to b, print Brazil, else if ch equal to c, print Canada, else if ch equal to I, print India. Else, that is if it is none of these options, then just print invalid entry. Okay, so this is one way of writing it. Now we need to write many else ifs, and in this case it is actually straightforward, simple. But suppose if you have more entries, say month number. Suppose if I input the month number, then it should output me the month name. If it is 1, it is January. If it is 4, it is April. If it is 10, it is October. Something like that. Then I need to write 12 cases. If else if else if all those cases I need to write. Alternate is switch. It does not make it extremely simple. Slightly simple. The number of characters you type will be less. As simple as that. Nothing really drastically simplified. It simplifies it to some extent. Okay, and particular kind of programs, when you have a program with a chain of else ifs. Okay, but if you have like nested if else, we'll look at an example later. Inside if else, you have another if else in one of these if else conditions. Again, you have another if else or something like that. Then switch is not that useful. So particularly when you have a chain of else ifs and you just want to list this item, do this item, do this, something like that, then switch statement is slightly more convenient than if else block. So So this scan ch, I won't write. So you write switch. You are checking the input. Okay, what is the nature of input, or what is the value of the input? So here you write something called case. Case is a keyword, which means if the value of ch is a, in case the value of ch is a, then you put colon and you write whatever you want to do. Print America. And then you also need to handle the case where I want to print America and stop, right? In the earlier case, how were we stopping? We were also using else if. So if it was A, it will enter only that if block. It will not enter any other block. Else if block, it will not enter. Okay. Similarly, we want to stop it from entering other cases. So we need to put a break statement. And then next case, if it is B, then print Brazil. Again, put a break statement. If it is C, print Canada. Then again put a break statement. If it is I, print India, break. If it is none of these cases, then we write something called default. So default means it did not match with any case. It's like else condition in if else chain. Print invalid entry. Here it doesn't matter whether you write break or not, because it is the last statement in switch. It will anyway come out of the switch statement after this. Okay, so so there are a couple of things which you need to notice. One, switch, like if, it has a condition and then opening and closing braces, and inside the cases they don't have brackets. You put a colon after each case. This only this portion, case portion, looks similar to Python. You indent here. Indentation is not necessary, but colon is important. So you don't put brackets here. You put a colon after the case, and you write whatever statements you want to be executed inside that case. All right. Now, like if else chain, each case, you see, with the break statement plus the case acts like else if. Without the break statement, only the case will act like if. Yeah. So what is the difference between if and else if? If I just put if, whether the previous case is true or not, it will test this case also. Okay. If I put else if, it will test the current condition only if the previous condition is false. Okay. So that is the difference. Similarly here, if I put a break, it will not check any other cases. It will get out of the switch statement. You will learn break better when we get into loops. Basically, inside a loop, whenever you write a break statement, it will break out of the loop from that point. Okay. Similarly here, whenever it sees break statement, it will break out of the entire switch statement. It will not look at any other remaining statements in the switch block. Okay. But if you don't put a break statement, here there's a slight difference between if and the case. In the case of if, whether the previous if condition is true or false, it will check for this if condition. If it is true only, then it will enter. But here, if you don't have a break, whether the next case is true or false, it will enter that case. You see the difference? So here, suppose if I write if ch equal to a, print America. If I write if ch equal to b, print Brazil. In this case, what is happening? If ch is a, it will print America. If ch is not a, it will check if ch is b, and only if ch is b, it will print Brazil. Okay. If ch is a, it will print only America. Then it will check if ch is b. If ch is not b, so it will not print Brazil. So it will check both the cases, but it will print whichever case is true. Okay. But here, if break statement is not there, suppose if my input is a, it will print America. then it will not check for any other cases. It will just print all the statements until it finds a break statement. That is the difference. The only first case it will check. The correct entry point will be correct. If it is A, it will enter case A. If it is B, it will enter case B, and so on. But once it enters, until it sees the break statement, all the remaining cases it will ignore. It will ignore checking the cases. It will just execute all the statements. So let me just do it and show you so that you will understand what is happening. I'll just show the switch example, no need of if else. You already understood that. So let's say some character, and the character, and then switch. What if I don't put a single quote, single quotations around the character? What will happen? Single quotes if I don't put? It will not. It will assume it to be a variable and looks for the variable declaration in the declaration statements. If such a variable is not declared, it will give an error. Okay. So if you want to treat something as character, you necessarily have to put single quotes around it. If you don't put single quotes, it will treat it as a variable. All right. If it is a string, you should put double quotes. We will see. We will look at strings later. So case A, printf, and print a break statement. So I'll copy this. Okay, it doesn't matter whether I put break statement here or not, but anyway, let's just check this. Suppose I write B, it will print Brazil and exit. If I write I, it will print India and exit. If I write A, it will print America and exit. If I write C, it will print Canada and exit. If I give any other input, it will just print invalid entry and exit. Okay. Now let's modify this slightly. Suppose I remove this break statement. Let me remove this. Okay. Now if I give A, it will print America and exit. But if I give B, what will it print? It will print both Brazil and Canada. Although the case is not C, still it will enter that case because there was no break statement before. Okay. It will not check for any more cases. Only the first case, entry point, it will check. You are giving B, so it will enter the correct case. It will print that. After that, it will just flow automatically to the remaining statements and execute all of them until it sees a break statement. Okay. So A, America, it printed and stopped. B, it printed both Brazil and Canada. If I enter I, what will it print? Only India. It enters at that correct point. After that, there is immediately break statement, so it will print India and stop. Okay. Similarly, any other entry is invalid entry. Now, suppose now here giving break or no break doesn't matter. It doesn't make a difference. Whatever is the last one, it doesn't make a difference, right? Because it is anyway going to come out of the switch statement. Break matters if you want to break in between, somewhere from between, you want to come out of the switch statement or any statement, any block. Okay, that's when break is necessary. Now suppose I remove this break also. Okay, now if I give C, what will it print? Canada and India. If I give B, what will it print? Brazil, Canada, India, right? If I give I, only India, right? Yeah. If I give C, it prints Canada and India. If I give B, it prints Brazil, Canada, and India. If I give I, it prints only India. If I give A, it prints only America. Okay. Now, it will print invalid entry also. Yeah, so let's see that. Canada, India, invalid entry. Okay. So whether it is default or a case, it doesn't matter. It will just execute all the statements. Okay. So let's change the position of default and say put it here. All right. And we put a break statement here. So now default will act like any case. In a sense, if you entered the case before default and there is no break statement there, it will enter default also. But if it doesn't, if your input doesn't match with any case, it will directly enter default wherever default is. So the order of the cases doesn't matter for the entry point. The entry point means whatever is the correct entry point, it will enter that particular case. If it matches with any case, it will enter that case. If it doesn't match with any case, it will just enter default. Once it enters, it will just execute the statements there. Now the order matters. Whatever are the remaining cases or remaining scenarios, it will just keep executing them until it sees a break statement. Whether the remaining scenarios are default or a case or whatever, it doesn't matter. Okay. So now if I input A, it will just print America. If I input B, it will print Brazil and invalid entry. Invalid entry and Canada. If I input G, invalid entry and Canada. If I input C, only Canada. Okay. If I input A, only America. If I input B, Brazil, invalid entry, Canada. If I input some random, invalid entry and Canada. Okay. Input C, only Canada. Input I, only India. All right. So that's what switch statement does. Now, one more thing which you need to understand in a switch statement is, okay, let me copy this. Without default, if you entered some other value, let's check that. Nothing. It's like you didn't give an else condition in if else. It doesn't do anything. It doesn't know what to do. That's all. Okay. Okay. One more thing. Another difference between switch and if else is in switch you are checking in if condition. What are you doing? In if condition, you are checking only whether a condition is true or false. Okay. You are not checking the scenarios where a condition may take different values other than true or false or a constant value. So suppose if suppose in switch you can have any complex expression, not only a variable, but you can have very complex expression. Suppose I can say int x, and I can scan that also from the user. This can be very complex. Any expression, x squared plus x cube minus 2x, whatever. Okay, so this expression will have a value, right? That value, you want to do different things for different values. If the value is 10, do something. If the value is 1, do something. If the value is -1, do something. So that is what you want to check, right? So in that case, basically, case, when you say case A, or in this case, how do we write it? If I say case 10, do something. Case 1, do something. Case -3, do something. So what are we doing? The cases are nothing but the possible values of the expression in switch. Okay. So the case value in case whatever you're writing, case A, case B, or case 1, 2, 3, whatever they have to be numbers or characters. That's all. In cases, you can't have expressions because an expression itself can't be a value of another expression, right? An expression can have a value which is a number. All the expressions which we saw, all different kinds of expressions you take, logical expressions, relational expressions, bitwise expressions, all any operator you use, finally you will be getting a number. It can be 0 or 1, or it can be any number, right? You won't get an expression as an output for an expression, right? So whatever expression you are giving inside switch, it will have a value. It will be a numerical value, or it will be 0 or 1, or whatever it is, it will be a numerical value. So what you are doing later is you're checking if the value of this expression is so and so, do this. If the value of this expression is so and so, do this. So cases are checking the values of the expression in switch. And since a value is always a number, cases can always have only numbers or characters, because character is also finally a number. It has a one-to-one mapping with a number, like you saw earlier. If I want to check if a character is falling between small a and small z, instead of finding their ASCII values and comparing with them, I could directly use the characters and compare with them, less than or equal to, greater than or equal to. We were able to do that because character itself is a number. Similarly here, character itself is a number. That's why we were able to earlier check case A, case B, and so on. Okay, so cases will have only constant values. Switch condition can be any complex expression. Okay, that is the main thing. The values which we give in cases are the possible values of the expression in switch condition. So case itself can never have an expression. So you can't put a case like okay, case small a or capital A. This you should not do. You cannot do, because small a or capital A itself is a logical expression. This logical expression cannot be the value of any other expression. This expression you can put in switch, and the value of this expression will be either 0 or 1. So then you say, in case 0, do something. In case 1, do something else. Right? That's all you can do. Okay, got it? Yeah. All right. Okay, so switch statements we saw. If else, yeah. Now in if else, there is nested if else. We already sort of covered an example, but I just covered one more. So this is again a flow chart. Basically, what is it saying? It's just saying you should maintain your speed between 70 and 80. If it goes below 70, increase your speed. If it goes above 80, decrease your speed. Just maintain your speed between 70 and 80. All right. So one way of converting it into if else is, whatever is the true branch, you put that in the if block. Okay. And whatever is the false branch, you put that entire tree in the else block. Now within this else block, again you have a subtree. Within this subtree, you have a true branch and a false branch. So this is the if block, this is the else block. Within this, whatever is the true branch, you put it in the if block. Whatever is the false branch, you put it in else block. So this is nested if else thing, right? So what are we doing? So first we will check if speed greater than 80. What should we do? Slow down. Okay. Slow down. And then else. So this is this entire tree else. Within that, I should check if this thing is true or this thing is false. So within else, I should write if speed is less than 70, then what should we do? If it is less than 70, speed up to 75. else don't change. So this else goes with this if. Okay, and both this if and else are within this else. All right, and this entire block of else goes with this if. So this is a nested thing. Fine. Now, okay. So this is one way in which we can convert this if else thing, convert this flowchart into nested if else. Another way is you take this thing as an if condition, and then you take this entire thing as an else if condition, and if imagine the tree is larger, then you take the next entire thing as an else if condition, and so on, and in the last node you consider it as the else condition. Okay, here the tree is growing only in one direction, so it is easy. So the same thing you can write also as if speed greater than 80, slow down, else if speed less than 70, speed up to 75, else don't change. Okay, so in else if what is happening? Else if is handling both the scenarios. Else if is it is checking that the previous condition is false and if the current condition is true. Okay, so if you have this chain of else ifs, any particular else if will work only if all the previous cases are false. Okay, similarly in this tree you will reach this stage only if this thing is false, and you will reach this stage only if this thing is false. So only if all the previous parent nodes are false, you will reach the rightmost child. Okay, so there are two ways of solving this. Now in this particular case we have been able to map this to a chain of else ifs because the tree is growing in only one direction. But if the tree were growing in a different directions in different places, you see in the left side the if else nested if else, what is happening, that is also growing in one manner. First I have an if else, in the else part again I have a sub block, another if else. Now within this sub block in the else part again I have a sub block, another if else. Within this if else again in the sub block I will have, in the else part I will have sub block. Okay, so here only the else part is getting a sub block. But imagine if the tree is growing in a different direction. Right now it is growing linearly like this, but suppose at some point it grows this side, after some point it grows this side, after some point it grows this side. Then when you are having this cascading if else nesting, in some block if may be having a sub block, in another block else may be having a sub block. Right, suppose in the first if else is having a sub block. Now within this inner if if may be having a sub block. Now in that sub block else may be having a sub block, in that sub block again else may be having, in the next sub block if may be having. So it may be sort of oscillating between an if condition and an else condition in the inner blocks. In that case else if will not work. In that case you can't translate it easily into else if chains. Okay, in this case it is easy to translate it to else if chain because the tree is growing in only one direction. Got it? Yeah, as simple as that. Anyway, don't think of it as rules. Okay, if the tree is growing like this, then I need to use else if chain. I can use else if chain. If it is growing in different directions, I can't use. Don't think such in a calculated method. Just try to use your common sense. Whatever your common sense is saying, that is straightforward. Just use that. Okay. If it is too complicated, don't worry about all these rules. Whatever your common sense is saying, if else is quite straightforward thing, basic common sense thing. All right. Okay. Yeah. So this is like a flow chart for else if chain or switch statement. First condition, if it is true, you execute block one. Else, as long as the conditions are false, you keep going. It's a chain. And finally, The last one is an else condition. Similarly, in a switch, if the first condition is true, you execute that. Otherwise, in the second case, you execute that. Otherwise, third case, you execute that, and so on. And finally, in the default case, you go to block n+1. That's it. So usually, else if chain is translated to switch. That's all. But if it is a nested if else kind of thing, again, translating that to switch is difficult. Okay. Yeah. All right. So we sort of covered almost everything related to if else statements and switch statements. We covered basic if else and nested if else and else if chain statements. All these things we covered. And like I mentioned earlier, in the chain of else if statement, anytime you will have only one if condition and one else condition and any number of else ifs. Any number of else ifs can come in between. Okay. And so on. Nested if else also we just saw. Switch statement we saw. Now I want to cover a couple of things which I could not cover earlier. Those are some math functions. You see, you already did some programs on basic mathematical calculations like calculating area of a square or a circle or a rectangle or some arithmetic operations. But you did not do programs which find out the square root of a number or log of a number or power of a number, right? So C has inbuilt functions for them. You can build some of them from scratch or all of them from scratch, in fact, because someone already built these functions also. But these are some primitive functions which you can start using directly. Okay, you can make use of them rather than building everything from scratch. So let me give an example of some math functions. So to use these math functions, you should include another library called math.h. They won't be present in stdio.h like square root or power. They are present in math.h. So you need to include that library. All right. So suppose I have a real number and I want to find its square root. All right. So there is a function called sqrt. You should use that to get the square root of a number. Fine. So let's execute it. All right. I should scan X first. Okay. You see now it's giving an error, but this error is not because our code has an error, but there is some linking problem. When particularly this is specific to math library. So when you are compiling, it wants you to link with math module. Okay. So you add this parameter called -lm. Now there is no error. All right. So when you are using math functions, in case you are getting such an error, just add -lm parameter with GCC. If you are working on Euclid, you need not worry about it. Euclid automatically does that. But if you are doing on your local machine, if you are getting this error, add this parameter -lm. Okay. All right. So now let's give an input. Let's say 4. Let's say square root is 2. 16 square root is 4. I'll give some arbitrary number. It's calculating the square root. All right. So square root is one function. Then similarly, there are other functions like log of a number, right? So there is a function called log. So log always has a base, right? So log n base something. If you don't specify any base, the default base is e. Log n base e. So here it will be log x base e. All right. So again, it's giving an error. So give -lm. Some number I will give 100. It will give some value. 100 base e is this whatever. So you are getting log x base e. Suppose if I want log 10, right? Then the function is log 10 of x. If I want log 2, log base 10, then the function is log 10 of x. If I want log base 2, then the function is log 2 of x. Okay. So yeah, these are the three main logarithmic functions that you need to know. So let's give an input. I keep forgetting. Yeah. Suppose if I give 100, then log 10, log 100 base 10 is 2. Log 100 base 2 is, what will be the decimal value? I mean, not the, huh? Yeah, 6 point something. Because what is the greatest power of 2 below 100? 64. Above that, it will be 128. So 64 base, log of 64 base 2 is 6. So it will be 6 point something. Log 100 base 2 will be 6 point something. You see? Log 100 base 10 is 2. Log 100 base 2 is 6 point something. Let's give let's give 64. Log 64 base 10 will be 1 point something. Log 64 base 2 is 6. Okay. That's it. All right. Then we have functions for ceiling of a variable. You heard of these functions, right? Ceiling, floor, rounding. See, ceiling floor is quite simple. Suppose if I have 5.2, what will its ceiling be? 6. What will its floor be? 5. When you round it, what will be the closest integer? 5. That's it. If I have 5.7, ceiling and floor will not change. When you round it, it will be 6 instead of 5. That's all. Okay. Expects argument of type int as type double. Okay. So let's change this. Okay. Now let's see. Okay. So they say 5.2. Ceiling is 6. Floor is 5. When you round it, it is 5. If I give 5.7, ceiling is 6, floor is 5, but when you round it, it is 6. Okay. 5.5. Let's see. Taking 6. Okay. Similarly, you will have. So I will keep the previous statement also as it is. Actually, in this case, it doesn't matter. Float and double both will work. Only int and float, int and double, they will have an issue, but I'm just keeping it in case. Okay. So I will. Yeah. And then we have f absolute for a double or a float variable. For an integer, you just have absolute. Okay, so that will be like int x. You need to scan also. Okay. I will run this later. Okay, so let's see. This is fine so far. Yeah. Whatever, 5.6. You just give 5.6 minus 5.6, 5.6. Absolute, right? Um, okay. This is part of stdlib.h. So let's include that also. Yeah, now no error. I give 5, it will be 5. I give -5, it's 5. Okay. And finally, we have something called the power function. I, no, power is for integers. Uh, so so we need two variables for power function. So let's declare them and let's scan them. Okay, hope it's fine. Oh, seems it is double. Okay, okay, okay. So double. No, I shouldn't change. That's this. So let me modify this only. Okay. Mm, yeah. So let's change this. Okay. Yeah. Uninitialized. Again, scan Y. Right. Uh, okay. So 5 and 4, 625, or 5 and 2, 25, 2 and 5, 32, and so on. Okay. So in case you're not sure of the input output data types, we may not remember every function's input output data type. So in C, there is a command called man. It is for manual pages of any function. So man, a particular function. So you will get all the important things like this power function. Its input types are double and its output type is also double. Power F, its input types and output types are float. Power L, its input types and output types are long double. Okay, so like that. Similarly, say if you want to check man sqrt, you will get its details. Okay, this is in Linux. Otherwise, you will find on internet also man pages of a function or just the definition of each of these functions. You will get that. Okay. Yeah. Yeah. So that's what I wanted to cover. So let's stop here.